what we have over here is integration without limits. Okay, so we have 4x, the square root of x squared plus 1, and that is what we have to deal with. Okay, let's see how we go about it. First and foremost, okay, this is the question. The integral of 4x all over square roots of x squared plus 1 dx. Okay, so we can use U-substitution to make the equation less complex. So select our u to be equal to x squared plus 1. Okay, so with that, when I differentiate, I'm going to get du dx to be equal to 2x. Okay, my interest is on making dx the subject. So the dx now will be equals to du all over 2x. Wow, this is what I have. So therefore, as we said, let u to be equal to x squared plus 1. When we differentiate du dx, we get 2x. We'll make the other subject. Then we'll do substitution back into the equation. Then our equation will be the integral 4x all over square root of u multiplying dx. Okay, and so which one is our dx? Our dx, as we can see clear, is this and that. So we gotta substitute this into this back there. So our integral then will be 4x over square root of u multiplying du over 2x. Okay, we realize that this, we can do some cancellation. We will cancel this and that. Okay, we will be left with 2. So that I will say that our equation now, the integral, is given as what? 2 out du over square root of u. Okay, this, we can equally say that this is 2 out u raised to the power negative half du. Okay, I hope this one makes sense. So now we know that if we have an integral xn, okay, and we want to work it out, it's xn plus 1 all over n plus 1 plus c. Okay, the same way, if we compute what we have so far, then this one will be 2 out. Okay, this is u minus half plus half all over minus half plus that. Okay, that with this plus a constant c. Okay, this is 2 out is u half all over what? Half plus c. This can be written as 2 times 2 u raised to the power half plus c. As we saw earlier, okay, so as we go down here, then we'll say that through integration, so we have 2 times 2 u raised to the power half plus c, which can be written as 4 times u raised to the power half plus c. Now look at it. But we know that our u, as we started, when it was equals to x squared plus 1, we forced that. We shouldn't forget that. So if we do back substitution, then this can be written as 4 times x squared plus 1, the square root of that. Because well, we know that the half over here means the square root of u. So when we substitute that x squared plus 1 back into the equation, then this equation can be written as 4 out square root of x squared plus 1, yeah, square root of x squared plus 1 plus c. Foremost, the question we faced with was an integration without limit. Okay, when we say without limit, that's we don't have any limit, any values ranging from a certain value to from lower value to upper value. Okay, so because of that, then we know that we have to introduce a constant into the final integral. So our first idea was we said let s squared, let u equals s squared plus 1. We said let u be equals to s squared plus 1. Then we differentiated this. We differentiated to get this. Okay, so when we differentiate the u over the x will be 2x. Don't forget that if you have something like y, if I have a function f of x to be equals to xn, okay, we normally say that let the function f of x to be equals to y. So the y is equals to xn. So dy dx is always given as what nxn minus 1. Don't forget that. Okay, try not to forget that. That's it's fundamental. Okay, so that's what we applied to differentiate this. And when we differentiated it, we had du dx, changing u with respect to x equals to 2x. Okay, but our interest was dx. So that's why we arrived at this. Okay, then we substituted this into this equation. Then we did cancellation. It's common. This is not integration. It's common cancellation. Have you seen that we have 4x and a 2x? When the x cancel the x, okay, then 2 will go into 4 two times. So that's why I put 2 outside the integral. Square root of minus half, because the 1 of that will be minus half. After that, then we revised that if we integrate x raised to the power n, then our integrand will be x raised to the power n plus 1 and n plus 1 plus c. So that is what I have applied over here. Okay, so I bring the 2 out. This will be 2 raised to the power minus half plus 1 divided by minus half plus 1. Okay, then this simple computation, when we compute this, okay, when we compute this, we will end up having 2 times 2 multiplying u to the power half plus c. So eventually this is what we get. Okay, then everything is supposed to be in terms of x, but not in terms of u, because we substituted the u. So we have to put a u back. And when we do that, the u goes here to the place where it is. Then finally, we arrive at this. And this is the integrand. So the integral. So in a nutshell, we can say that the if you integrate 4x all over s squared plus 1 dx, our answer is 4 square root of s squared plus 1 plus c.